If 2 to the power of r is 16, 5 to the power of s is 25, what is the value of r plus s? 2 to the power of r is 16. Well, 16 is 2 to the power of 4, so that means r is 4. 5 to the power of s is 25. Well, 25 is 5 to the power of 2, so that means s is 2. So r plus s would be 4 plus 2, and that is 6. X plus y over 2 is 5. X minus y over 2 is 2. What is x squared minus y squared? X plus y is 5. Well, x plus y over 2 is 5, I should say. And therefore x plus y would be 10. X minus y over 2 is 2. So therefore x minus y would be 4. And then this expression, I think all of you know, can be factored very easily. X, y, y, positive, negative. So x plus y, we got that was 10. X minus y, we got that was 4. And therefore this is 40. The sum of two positive integers is 60, and their least common multiple is 273. What are the two integers? If you're not familiar with LCM, I encourage you to become familiar. If you have the LCM of two numbers, they're saying it's 273. Now, least common multiple, you have to think the biggest. And no, I did not misspeak there, and I'll explain what I mean. But first, we have to figure out what is 273 in terms of its prime factors. And it's 3 times 7 times 13. Okay, so that means that if we have LCM of two numbers, and that is 3 times 7 times 13, these guys are going to be 3, 7, and 13 also, but we don't know what power. It could be power of 0, right? If it's a power of 0, then it would just be 1. Now, what does this think biggest mean? It means that if you look at this number and this number, you have to choose the biggest power of each prime number to go here. So that means the biggest power of each prime number in this case is going to be just 1. But we have to figure out how are we distributing that 1 and how are we distributing the zeros. So they give us another clue, and that is the two positive integers add up to 60. So you got to think about this now. Let's see here. If I made this a 1 and I made this a 1 and I made this a 0, that number would basically be 3 times 13, which is 39. And then if I made this, let me think about this. So I can only use 1s and 0s. I'll make this a 0 exponent, that one or that one, that'll be a 21. And therefore, that would work. And it will work over here also because 39 plus 21 is indeed 60. So it just takes a little bit of kind of thinking. And I think that's what they wanted. They wanted the two numbers. What are the two integers? So the two integers are 21 and 39. In the diagram, AB is perpendicular to BC and CD is perpendicular to AD. Also, AC is 625, AD is 600. If BAC is 2 times DAC, what is the length of BC? Let's see here. I think if this, for example, is theta, they're saying that's 2 theta. And what do they have to do? BC. So let me just call that X. I think we're going to have to use trigonometry here. So cos of that theta is 600 over 625, I believe. And you are allowed to use calculators on this exam. So therefore theta is approximately 6.26, and therefore 2 theta is approximately 32.52. And then the other bigger triangle, we will use sine. So the sine of 2 theta would be x over 625. And therefore 625 times the sine of 32.52 is x. And then you crunch out these numbers. And when you do, you should get exactly 336. A circle has center O and a diameter AB, which is equal to 2 root 19. Points C and D are on the upper half of the circle. A line is drawn through C and D as shown. Points P and Q are on the line so that AP and BQ are both perpendicular to PQ. QB intersects the circle at R if CP is equal to DQ is equal to 1 and 2AP is equal to BQ. What is the length of AP? All right. Oh boy, I gotta draw some lines here. So I'm trying to think what would be the right way here. The first line I'm going to draw is from A to R. Yeah. Okay, that's pretty decent there. Then I'm going to draw I'm going to draw a radius. So O to C. Yeah, that's a radius. And then one more line. I'm trying to think what would be. I think a line that let's see here. A line that cuts that CD in half. So something like this. I hope that looks right. Okay, so let's move forward with this. Now we got these lines drawn. And hopefully this won't be... Let me expand this or increase this a little bit. I think that's a little bit better. Okay, now let's label this all. So that I'm going to label X. This one we already know is Y. 1, sorry. That is 1. That's given in the question. The CD I'll just call Y. This is root 19 according to the question. That's root 19 because the diameter is 2 root 19. And then since that... Okay, they give us some angles here, right? Perpendicular, right there. So that means this is a right angle. And this is also a right angle. And if you look at the triangle ARB, right? That sits in a semicircle. So by definition, that is also a right angle. So that's interesting because that basically means that PAQR is a rectangle since all of the angles are right angles. Okay, just trying to fill in the information first before we tackle the question here. Is there anything else I need to fill? Well, they told me that Q to B, BQ is 2AP. Okay, so that means Q to B is 2x. So since AP was x, so that means QR would be x since it's a rectangle and therefore the sides are the same. And therefore R to B would be x. I know it doesn't look like that, and sorry about that. I tried to make it, look according to scale, but you guys understand. Okay, anything else that I need to do here? I think that should be good enough. So let's proceed with the question here. Okay, so let me shrink that back down since I needed to kind of. Okay, all right, that's pretty decent. All right, so what's the next step here? Well, I think a lot of Pythagorean relationships here. For example, in triangle ARB, I think ARB, yeah, that triangle is going to be AR squared plus RB squared is equal to AB squared. And let's see if I have all these things. AR is going to be the same as PQ, and PQ is y plus 2. So that's RB is x, and AB is 2 root 19. Okay, yeah, I have everything. I mean, we got variables, but at least I can plug it in. So this is going to be y plus 2 squared. This is going to be x squared, and then this would be 19 times 4, which is 76. And I think that's about as far as I can go with that. So we'll just call that equation 1 for now, and I'm certain we're going to come back to that later. Okay, so now I'm going to have to label this a little bit. This intersection point right here, I will call T, and this point right here up there, I'm going to call M. Okay, so now we've got two triangles that are similar. It's ATO is similar to triangle ARB. So that basically means that AO over AB is equal to TO over RB. So now let's fill in what we have. AO is root 19. AB is 2 root 19. TO, that's what we don't have. And RB is just x. So that means that this would be x over 2. So let me just put that in there. That'll be x over 2. Squeeze that in there. Okay. And then, what else? I need another equation because I've got two variables here. So I need another equation that has x's and y's. Otherwise, I can't solve for it. OM, that entire thing from O to M, looks like it's going to be x over 2, which is OT, and then MT is just x, right? Because MT is the same as the sides. So that's 3x over 2. Okay, and then what triangle? OMC, I think. Yeah, because that radius that I drew has to be taken into consideration. So in triangle OMC, yeah, there, that is going to give me my second Pythagorean relationship. So that's going to be basically CM squared plus CM squared plus OM squared is equal to the hypotenuse, which is OC squared. Okay, got it. And then CM squared, that CM squared, okay, that's y divided by 2, right? Because that line cuts that CD in half. So that's y over 2. And then OM, I just got here, so that's 3x over 2 squared. And then OC is the radius, so that's just root 19 all squared. Okay, we got it. Well, we got the equation, so let me just simplify this first. Y squared over 4 plus 9x squared over 4 is 19, and then multiply through by 4, get rid of the fractions. There'll be y squared plus 9x squared is 76. Okay, well, we got equation 2. So we'd use these two equations, and then we'll solve for x and y, and in the end, what are we trying to find? The length of AP. So AP is find x, basically, according to my labeling, which is AP. Okay. All right, so we just have to find x. Okay, so let's do that. Let's see here. I will... what will I do? I'll just use this guy here to first isolate for x squared. So x squared will basically be 76 minus that y plus 2 all squared. Got it? And then I'll plug that into there. So we got y squared plus 9x squared, and x squared is 76 minus this y plus 2 all squared, right? Which is 76. And then now we can expand this. It shouldn't be that hard. Okay, so let's see here. Y squared plus 684 minus 9y plus 2 all squared is 76. Let's see if I can put everything on one side. 684 minus 76, that's going to be 608. And if you put this on the other side, it'll be y plus 2 squared, 9 minus y squared. Okay. All right, so obviously we have to expand, so this will be 9y squared plus 4y times 9, so 36y. And then 4 times 9 plus 36 minus y squared. So if we put everything on one side and collect like terms, it would be 8y squared plus 36y minus 572. Divide through by 8, and we'll get y squared plus 4.5y minus 71.5. I know you're not supposed to use decimals, but that's okay. And I think I can factor this. y 6.5, 11. Positive, negative. So y would be 6.5. And then, of course, we're going to sub it back into there because we need the value of x. That's what we have to figure out in the question. So x squared is equal to 76 minus y plus 2 all squared. So x squared would be 76 minus 6.5 plus 2 all squared. So it'd be 76 minus whatever that is, 8.5 squared. And this is 3.75 for x squared. And 3.75 is what, 15 over 4? So therefore x would be root 15 over 2. And that is what they wanted, which was AP. A bag contains exactly 15 marbles, of which 3 are red, 5 are blue, and 7 are green. The marbles are chosen at random and removed one at a time from the bag until all of the marbles are removed. One color of marble is the first to have 0 remaining in the bag. What is the probability that this color is red? We have a bag initially with 15 marbles. And those 15 marbles are 3 red, 5 blue, and 7 green. And then eventually, I'm going to kind of go through phases here. We want eventually to get to a situation where we have 0 red, but we do have some blue and some green. Now, that, I don't know how many are in there, but we want 0 red because we want the red to be the first to have 0 remaining. So that's what basically this means. And then eventually we keep going, and we are going to eventually have a situation of there's two possibilities. Either we have a situation where we already have 0 red, so that is always going to be a 0. This is a 0 red, but we can have a situation where we have 0 blue as well, and we still have the final green. So that's this guy right here. Or we can have, let's put or we can have this situation where you have 0 red. I know that's confusing. 0 red. Let me put a line through that to separate the 0 red from the or. They look exactly the same. Or we can have 0 green, but we have 1 blue remaining. And then at the very end, when you remove that final marble, you'll have 0, 0, 0 basically. 0 red, 0 blue, and 0 green. And that's when it's all finished. You've removed all the marbles. So that's sort of the pattern. So what they're asking for probability. So probability questions, as always, usually a fraction. The bottom is the total, and the denominator, I should say. And the numerator is our specific condition. So first, let's talk about what is the total. The total is from 15 different ways. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So for the first marble, you have 15 choices. For the second marble, you have 13 choices, and so on down, all the way down to 1. So 15 factorial is sort of the total number of ways, total number of orders, I guess, that they can be removed. But this 15 factorial has a lot of duplicates. So to eliminate the duplicates, you have to divide by how many you have of each, which is 3 factorial, 5 factorial, and 7 factorial, to account for the ones that are multiples, the duplicates, basically. So that is what goes in the denominator, 15 factorial over the 3 factorial, 5 factorial, and 7 factorial. Now the numerator, that of course is a little bit more complicated. So the numerator, which is our specific condition, that's what we need to figure out next. And then of course we'll come back and put it in the numerator. Okay. So our specific condition is that we want this. This is our specific condition right here. That we want the first to have 0 remaining to be red. And that's what these are. Both of these scenarios have 0 red as the first. And they still have either 1 green or 1 blue. So that first scenario I will talk about, and that is scenario, I will call it scenario A, and that is that the last marble is blue. So that's this guy right here. See that one? The last marble is blue. Okay, so let's talk about this here. The last marble is blue. Now, initially there's 5 blues, right? So there's 5 blues initially. So B, 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 like that. But we want the last one to be blue. So if we got 15, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we want the last one to be blue. So that means this guy is going here, the last one. So that means that from the remaining 14, you've got to select 4 of them to be these 4 blues. Okay? So from the 14 slots before the last one, you got to select 4 of them to be the blues. Okay. So then now we got to discuss this a little bit. How many slots do we have left once you put the 4, once you've, I guess, removed 4 from those 14 slots, you'd have 10 slots, right? So you've got 14 slots, and then you're going to put 4 of them as blues. You got 10 slots left. But here's the thing, you have to remove 1 more. Why? And I think that's the hardest part of the question. Because here's the story. This guy, the second last guy, can't be an R. Because if it was an R, then that would not be the last, that would not be the first color to reach 0. Because if that was an R, then that means that the greens have already turned to 0. You see what I'm saying? So that can't be an R. So that has to be, I guess, something else. So the reason we're subtracting the 1 is that for the final G, for the final green, it must be after the final R. So that's it's fixed like that. So it could be here, but it could be somewhere else, right? Because that could also be a B, I believe. So we gotta subtract that 1. So that means we actually have 9 positions that we have to select from. So from the remaining 9, which is the equivalent of 14 minus 4 minus 1, we have to select where we put in the other G's. Now in total, how many G's were there? There were 7 G's, right? Yeah, 7 G's. So since there was 7, and this guy accounts for 1 of the G's, we have to select the other 6 G's. So for the G's, the 6 G's, and this was the 4 B's. So, yeah. So the total for that scenario would be that 14 choose 4, and then the 9 choose 6. And of course, you have now 3 spots remaining, and for those, you select all 3 of them for the reds. So this is for the reds, this is for the G's, and this is for the blues. So I hope that made sense. I hope. Okay, so now we got to do the same thing, but this time the last marble needs to be green. So this guy right here, this guy. So it's very similar to what I just did. So hopefully the second time it won't be as difficult to understand. So the second scenario is the last marble is green. Okay, so same thing. Very similar. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So we've got the last marble is G, so just put that G in there. And this guy can't be an R for the same reasoning as above. So from these 14, you've got to choose 6 for the G's, because there's 7 and they put 1 here. So there's 6 G's remaining. And then remember, there's 14, but you just subtracted 6, but you've also got to subtract 1 because that 1 is for the final B. Because that final B must be after the final R in order for this to work. So that's got to be fixed. So therefore you actually only have 14 minus 7, so 7 spots remaining. And from those 7 spots you got to put in the B's, and there's 4 B's remaining because there are a total of 5. So there you go. So that's for the B's. And therefore, if you combine it, it'll be 14, choose 6, 7, choose 4. And then for the remaining 3, those are for the R's. So this is for the R's, this is for the B's, and this is for the G's. Okay, so we got it. So we have this one, and we have this one. So the numerator that I'm going to put this guy and this numerator up here, this guy, is this plus this. So it's let's see here, put it in the same screen. So the numerator is 14, choose 4, and then what was that? 9, choose 6, plus 14, choose 6, and 7, choose 4, because the 3 choose 3s are just 1. So then when it's all put together, we basically have the following. The probability is this 14, choose 4, 9, choose 6, plus 14, choose 6, 7, choose 4, and all over the denominator, which I had previously calculated as 15 factorial over 3 factorial times 5 factorial times 7 factorial. And I'll let you crunch out these numbers, and when you do at the very end, you will get 21 over 40.